Good morning, students. Our today's experiment is to determine the coefficient of friction and friction losses in different pipes. Whenever I say different pipes, that means here we are only concerned with the pipes of different diameter. Of course, the pipes will be of same material and the length will also be the same. But here we will only be concerned with the pipes of different diameter, and we will see the impact of diameter on friction losses and friction factor. Here in the aim of the experiment, I have used the word coefficient of friction, but that is also known as friction factor. So we will determine both of them, and for that we require some apparatus. The first major apparatus is of course the fluid friction apparatus, and the second one is a stopwatch which will be used to calculate the volumetric flow rate, because volumetric flow rate is required to calculate the velocity of the fluid. Now coming to the theory part, here whenever any fluid flows through any pipe, there are two types of losses. The first one is major losses and second one is minor losses. So the major losses accounts for almost 80% and the minor losses accounts for around 20%. So the major losses mainly includes the losses due to fluid friction, whereas the minor losses includes the losses due to bends, fittings, sudden expansion, sudden contraction, and maybe sometimes due to entrance and exit also. The 2 points between which we will find out the head loss due to friction doesn't have any kind of bends, fittings, sudden expansion, sudden contraction. So we can assume that all the losses are mainly due to major losses and the minor losses is negligible. So that means we can say all the losses or head loss between those 2 points is only because of fluid friction. To measure major losses, we use one equation that is known as Darcy-Weisbach equation. It is given as HF is equal to 4F L V bar square upon 2 GD. So here HF is the head loss due to friction between 2 points. F is the friction factor, or we can say fanning friction factor, also known as coefficient of friction. 4F is known as Darcy friction factor. Then L is the length of the pipe. And V bar is the average velocity of the fluid through the pipe. G is the acceleration due to gravity, and D is the diameter of the pipe. In this equation, we all know the value of acceleration due to gravity. Then we can get the value of length and diameter of the pipe from the apparatus itself. And for average velocity, we can use the continuity equation, which is Q is equal to area into velocity, where Q is the volumetric flow rate. So we can get the area because we already know the diameter of the pipe. Then for volumetric flow rate, we can find the volumetric flow rate from volume of water collected per unit time, and then we can find the head loss due to friction from the manometric reading, which is given as HF is equal to H into rho m by rho minus 1. Here the H is the manometric reading, and when we will find all these values, then we can easily find out the friction factor. Before following the procedure, let's try to know about the apparatus first. So this is the apparatus which we call as fluid friction apparatus, and as we all know, here we need to find out the friction losses and friction factor for these three pipes which are of different diameters, and these are the points where we have connected our manometer, and as you can see, the length between these 2 points are same for all the three pipes. So we will take the same length for all the three pipes, and here it is a measuring tank. Here we will see the height of the water collected, and we already know the area of this tank, so we can find the volume and volumetric flow rate from there. And here is the manometer, and these are the valves for measuring pressure drop for different pipes. And here we have one pump is there, centrifugal pump is there to circulate the water we have. So these are the things we need to know about this apparatus. Let us start the experiment. So first we will switch on the pump, then we will open the valve for which we need to measure the friction factor and head loss due to friction. So first we will go for the pipe of largest diameter, and then we will make sure that initially this valve is closed, so that all the water will be stored in this measuring tank, and we will calculate the volumetric flow rate, and then we will open this valve and see the manometer readings. So now take a look at the manometer readings at this point of time. So as we can see clearly that there are some static error here, so we need to keep this in mind, because for all the subsequent manometric calculations we need to subtract this reading. Got the volumetric flow rate using this height and one stopwatch. And now we will open this exit valve, and then we will go for manometric readings. And before going to manometric readings, we can see there are different valves. So as we have choose to go for the pipe of largest diameter first, so you can see it is the pipe of largest diameter. So we will open that valve, those two valves. So here we need to open these two valves. Now we will go for the pipe of smallest diameter. So first we will close this valve and open the valve for the smallest diameter. Also we need to change it at the manometer also. So here also we need to close this and this also, and we need to open the valve for smaller one. So we will open this top one and here top one also. Now we will get the reading for head loss for the pipe of smallest diameter. Now the valve of smallest diameter pipe is open, and also these manometric valves are open, so we can see the reading for smallest diameter pipe, and we can clearly see the reading. The deviation is maximum here. This deviation was very less in the case of largest diameter pipe. Here initially I had chosen for the pipe of largest diameter and then the smaller one, so that we can get maximum deviation in the manometric reading. Similarly, we can do that the same thing for this middle pipe also. We just need to close this valve of the smallest diameter pipe, and then we can do the same thing what we have done in these previous two cases for the middle pipe also, and then we can get the manometric reading for that pipe also.